Okay, so from the I dash by IP value, we were finding the time of operation of the relay. Now the pickup current is defined as the percentage current setting into rated secondary current of the CT. I hope you can see this, right?
Yes, sir.
Yes, sir.
Yeah, the pickup current equals percentage current setting into rated secondary current of the CT. Now this is one representation, okay, because we are relating the pickup current in terms of rated secondary current of the CT. If it is 300 by 5, if the CT ratio is 300 by 5, then 5 is the secondary current rating of the CT. So that must be multiplied with the percentage current setting. If percentage current setting is 150%, that means 1.5 is the value, right? So 1.5 into 5, if 5 is the secondary rated current. In the example, it is shown that if CT is 500 by 10 amps and current setting is equal to 150%, then the pickup current equals 1.5 into 10, which is equal to 15 amps. Now that is 150% of 10 amps, right? 150% of 10 amps. Now when the relay coil current is greater than or equal to the pickup values, the relay operates, right? But how much time it will take for the relay to operate? To find that, we have to go to the inverse time characteristic of the relay. So for that, we will define a new term, which is the plug setting multiplier or PSM. Plug setting multiplier is defined as the ratio of actual fault current in the relay coil to the pickup current. So the actual fault current we know, right, that is seen by the relay, that is in the secondary of the CT, and its ratio to the pickup current will give you the plug setting multiplier. So sometimes in relay manuals, the inverse time characteristic of the relay will be shown in terms of plug setting multiplier. That means the horizontal axis will give you the plug setting multiplier, and the corresponding time of operation of the relay will be plotted on the vertical axis. So if you know the PSM value, the corresponding time of operation you can find. In some manuals, it will be I dash by IP itself. Okay, not I dash by IP. IP in the sense earlier we found this one, I dash by current setting. Okay, sometimes it is I dash by current setting, and so sometimes it is I dash by current setting into secondary rated current, which is pickup current. In the denominator, it will be pickup current. So that will be anyway mentioned in the manual. So accordingly, you can find the time of operation. Now we'll see how will we determine the time of operation of the relay. Now the PSM equals fault current in the relay coil divided by percentage current setting into rated secondary current of the CT. That is, your denominator is pickup current IP. Okay. Now the fault current in the relay coil is, an arrow is shown here. The fault current in the relay coil is line fault current into CT ratio, right? This is the power system fault current or actual fault current into CT ratio will give you the secondary CT current, actual secondary CT current, which is seen by the relay, or the current carried by the relay coil. That is in the numerator. Now we'll see the time PSM curve. This is the time PSM curve, the inverse time PSM curve. So for any PSM value, you can find the time of operation. Okay. Now another term is time setting multiplier. The value of time setting multiplier along with the time obtained from the time PSM curve decides the actual time of operation of the relay. That means the time setting multiplier is just a multiplication factor of the time of operation of the relay. The time of operation of the relay is found from this plot, right? If you know the PSM value, you will get the time of operation of the relay. If you multiply this with the multiplication factor, which is a time setting multiplier, you will get the actual time. The value of time setting multiplier along with the time obtained from the PSM curve decides the actual time of operation of the relay. Okay, now I'll give you an example here also. If the time setting multiplier is selected as 0.2, see, where have you seen this time setting multiplier, TSM, before? Anybody? No response?
Sir, could you repeat what you said?
No, this time setting multiplier, where have you seen before? In the previous lectures, anywhere? Anybody?
Somewhere in the graph.
Time delay over control is.
Yes, that's what. So basically in the Westinghouse CO8 relay characteristics, you might have seen several characteristics, right? Several curves, not only one curve. Several curves were there in which each curve corresponds to one time setting multiplier. Basically, that represents the multiplication factor. So if you get the time of operation of relay from one particular curve, you have to multiply that time with that the corresponding time setting multiplier. If you take it from another curve, then you have to multiply with the corresponding time setting multiplier. So it is basically each curve corresponds to a time setting multiplier. Okay, so if time setting multiplier is selected as 0.2, while the time corresponding to PSM of 10 is 4 seconds. That is from the inverse time Cara, you got 4 seconds corresponding to some PSM value. Okay, and here the PSM value is 10. Okay, for the PSM value 10, you are getting 4 seconds, suppose. Now this 4 is multiplied with what? Time setting multiplier, right? So 4 into your time setting multiplier is 0.2. So 4 into 0.2, which is 0.8 seconds. This is the actual time of operation of the relay. Okay, so this is the basic concept of time setting multiplier and plug setting multiplier. And knowing the CT ratio, plug setting multiplier, I dash IP, from these values, how will you determine the actual time of operation of the relay? Now let's see two problems which use this concept. The first problem, you can note down the data and you can start doing it. The IDMT overcurrent relay current setting. IDMT in the sense inverse definite minimum time overcurrent relay. What is inverse definite minimum time? That means in the curve you can see that for higher currents you have a constant value, almost constant value. There is a definite time of operation for the relay, right? And there is a minimum definite time for the operation of the relay, and the characteristic is inverse also. That is why it is known as IDMT relay here, inverse definite minimum time over current relay. Its current setting is given as 150%. Now the time multiplier setting is given as 0.6. The CT ratio is given as 400:5. The system fault current is 5000 amps. And you are asked to calculate the time of operation from the given characteristic. The characteristic is given below. Okay, before getting the characteristic, what should we know? If you want to find the time of operation of relay, what should you do? Anybody?
So we find the PMS value.
Yeah.
And then from the curve, we take the time and that times the TSM.
Okay, so find this value, PSM value. Do it.
7.5, sir.
7.5. That means, can you explain that?
The secondary current rated is 5 amperes from the CT ratio, sir.
Okay.
And I'm multiplying it by 1.5 because it's given that it is 150% of the total current. So I'm taking that the PMS. Okay, sorry. Oh, PSM will be the ratio. Okay.
Yeah. No, actually, the actual fault current is given here. The power system fault current is 5000. What is the secondary CT current corresponding to this fault current?
7.5 amperes, sir. That is
5000. No, 5000 into 5/400, right? CT ratio is given. CT ratio is given as 400:5. So in the primary of the CT, we have the actual fault current, which is 5000 amps. So in the secondary of the CT, we have 5000 into 5/400, right?
Yes, sir.
Yeah. So that means, yeah. Let me write here 1 minute. I'll write here. That's better. So, what is this? In PDF, is it like this, or can I adjust the thickness?
In PDF, it is like this only, sir. I mean, in PDF, it will be worse actually. In Adobe, if you open it.
This is Foxit. Anyway, okay, it's fine. I will do this. So it's fault current in relay. What is it? Actual fault current is 5000 into 5/400, which is equal to
62.5.
62.5 amps. Now this 62.5, what is the secondary rated current of CT?
5.
Secondary rated current is 5. Okay, secondary rated current is 5. Then what is the current setting? 1.5. So current setting is equal to 1.5. Then secondary rated current equals 5 amps. Now, how will you find the PSM? PSM equals 62.5 divided by, what is PSM? PSM equals 62.5 divided by, what is in the denominator?
1.5 times 5.
5 into 1.5, which will give you 8.33. Right, 8.33. Now go to the curve. Okay, so this is somewhere in between 7.5 and 10, right? 8.33. So suppose no, an approximate value. What is it? What is an approximate value? What will be an approximate value?
2.
Maybe 2.5, right? 2.5, maybe 2.5. I'm taking it as 2.5. Okay, so if it is 2.5, then that is a time in seconds. What should be done with that? That 2.5.
We multiply by that by TSM.
Yeah, so 2.5 from the plot right here. So 2.5 into TSM will give you the actual value, actual time of operation. What is the value? You're getting 2.5 into TSM.
1.5.
1.5.
Yes.
1.5. So let it be 1.5. Okay. So this is how you find the actual value of, time of operation of relay. Now we are going to the second question now. See the question. This is a part of a typical power system. Okay, part of a typical power system in which two relays are there, relay 1 and relay 2. Relay 1 has a setting of 125%. What is this setting? Current setting. Okay, this is the current setting of relay 1, which is 125%. And for relay 2, the current setting is 150%. Corresponding CTs are shown here, and CT ratios are 500:5. Then the fault is happening at this point. Okay, the fault occurs at this point, and the fault current is 4000 amps. Fault current means secondary CT current. Your not secondary CT current, primary CT current. This is the primary CT current. Okay, now two circuit breakers are also shown. Now, for discrimination, if the time grading margin between the relays is 0.6 seconds, what is the time grading margin? See, between these two relays, we have a time delay, because sometimes if there can be, I'll explain some 2 or 3 cases. Suppose the fault is here. Now the fault is here, right? So you know that if relay 1 properly sends a trip signal to this circuit breaker and this part is isolated. Can you see the cursor? Are you able to see the cursor?
Yes, sir. Yes, sir.
If this part is isolated, then it's fine, right? This does not carry a fault current further, because if your source is at the leftmost part here, then the source will not feed the fault current because this part is completely isolated now. Now, if your fault current is in between both the circuit breakers here, then which relay should trip?
Relay 2 will trip, sir.
Relay 2 will trip. So actually, according to the location of the fault, the relay should detect the location also, to which side of the relay it happens. That is also important. Okay. Now, if you have another source at this point in the second bus, let it be bus. Okay, the second node or second bus. Here you have one more source. Then what happens is, even though if relay 2 trips, and if your fault is at this point, that is in between the second bus and the circuit breaker 2, here in between this point, here is the fault current, and even though if relay 2 trips, what happens is the source at this bus will feed the fault current, right? So it depends on many factors, wherever the fault occurs and wherever the source is there, wherever load is there. So all these things are, it depends on all these things, which relay should trip. So sometimes both the relay may have to trip. So if in that case, sometimes both the relay may have to trip, or sometimes if relay 1 does not act properly, then relay 2 will have to trip. So relay 2 will wait for some time. After relay 1, there is a delay, time delay. This is what is a time grading margin between the relays, which is 0.6 seconds. Okay, so basically it's the time delay difference between relay 1 and relay 2. Now calculate the time of operation of relay 1 and time setting multiplier for relay 2. Refer to the characteristics given in figure T1. The same figure here. This is the same characteristic is applicable here also. So you are asked to find the calculate the time of operation of relay 1 and time setting multiplier for relay 2. Refer to characteristic given in figure T1. The TSM of relay 1 is 0.3. Please try this. Try it.
Sir, can you scroll up to the T1 diagram, sir, for reference?
Yeah, I'll do it. Yeah, yes.
Sir, a small clarification.
Yeah, tell me.
Previously we saw like in the Westinghouse time dial setting and this time setting multiplier, are these both same quantities?
Which one? Let me see. In which lecture?
Lecture 5.1, sir.
Lecture 5.1. 1 minute. Let me open it. Third one. This one, right?
Yes, sir.
This one, time dial setting. This is the same time setting multiplier.
Okay.
Yes, this is what I told. Several curves are there. Each curve corresponds to one time setting multiplier. So according to the PSM, if you are taking PSM on the horizontal axis, suppose if you are taking PSM on the, here it is taken as relay input current in multiples of current tap setting. Okay, this is a different value. Relay input in multiples of current tap setting. This is just a multiplier. Okay, so here if you take PSM in because this does not contain the secondary CT current. Secondary CT rated current, this value. In PSM, we have secondary rated current also, that's all. So whatever be the characteristic given, anyway, that horizontal axis will be labeled. So you will be able to find that value. Accordingly, you will find the relay operating current. And if the time dial setting or the time setting multiplier is given, you go to that particular chara and find it. Okay,
thank you, sir.
That's all. Yeah.
Sir, can you show the graph, sir, for T1?
Is it okay? Yeah.
Sir, can you show the question one more, sir, for the data, like the TSM data is?
1 minute. Here, this one?
Yes. 0.3. Yes. We can go back to the. Sir, what is the time grading margin, sir?
Time grading margin, if you want to find the operating time of relay 2, then you have to find the operating time of relay 1 plus the delay time. Delay time is time grading margin.
Okay, sir. Yes. Sir.
Yeah.
So is it 0.375?
1 minute. What is the actual time of operation?
Sir, for relay 1, I am getting 0.9 seconds.
Yes, sir.
0.9
For relay 1,
seconds
it's
is right.
0.9 seconds. For
0.9
relay 2,
seconds, that is right.
1.5.
Relay, that may depend on your, whichever value you have taken from the plot also, because it's
around
approximate only, right?
No.
For the second one, it is around 1.5.
Anyway,
Well, it will
0.9
be
seconds
exactly
for
1.5, right,
for
sir?
relay 1 is right. What is the value you obtain from the plot?
3, sir.
3 seconds. 3 seconds is okay. 3 seconds is taken here. Okay, for 6.4 PSM, right?
Yes, sir.
For for PSM 6.4, it is 3 seconds. Then for relay 2, time of operation of relay 1 plus time margin equals actual time of operation of relay 2. Okay.
Yes, sir.
Yes, sir.
What is that? It was 0.9, right? Time of operation of relay 1 was 0.9 plus 0.6 time margin. It is 1.5 seconds.
1.5.
Now, what about the fault current? Fault current is 4,000, right?
Yes, sir.
So how will it reflect on relay 2 CT secondary?
Current ratio is the same, so I think it will.
Same. So 5 by 500, right? So 4,000 into 5 by 500. It is 40 amps.
Yes, sir.
Yes, sir.
What is the PSM there?
PSM
5.33.
Yeah,
40
500.
divided by 5 into 0.5. 1.5. 40
Yes,
divided by 5 into 1.5, which is, I don't know what is the value.
5.33.
5.33. 5.33. Okay. So corresponding to 5.33, what is what you are getting from, what are you getting from the plot?
Approximately
4
4
seconds, sir.
4, approximately 4. It is 3.8 here. Okay, fine.
Yes, sir,
Then you have to
3.8.
multiply. So what what is the time setting multiplier then? Actual time of operation divided by time of PSM. 1.5 divided by
3.8.
3.8 or 4, whatever. Then what is the value? Final value? If it is
take
3.8, then
4,
0.4, right? Approximately 0.4.
yes, sir.
Yeah, fine. So that's it. Okay, now I'll just do it for those who have not done. Just go through it. Okay, so first we will take relay 1. 1 minute. Relay 1. For relay 1, what is the current setting? 1.25, isn't it?
Yes, sir.
What is the fault current? 4,000 amps.
4,000 amperes.
Yeah. Now what is the CT ratio?
500 to 5.
500 by 5. Now fault current in relay coil. Equals 4,000 into 5 by 500 equals 40 amps, right? 40 amps. Now what is PSM? 40 divided by
1.25 into
5 into 1.25, which is equal to
6.4.
6.4. Yes, good. Now Going down. Okay, from the plot. Now from the plot. From the plot, time for 6.4 PSM equals approximately equal to, okay, approximately equal to 3 seconds. 3 seconds. So actual time of operation. Actual time of operation equals 3 into TSM, right? Equals 0.9 seconds. Now for relay 2. Okay, I'm going to find for relay 2. For relay 2, what is the current setting? 1.5. Right. Actual time of operation equals actual time of operation equals time of relay 1 plus time margin, which is equal to 0.9 plus 0.6 equals 1.5 seconds. Now, what about the fault current? Same, right? Fault current is same and CT ratio is same. So fault current at secondary of CT, fault current at secondary CT equals same 40 amps. Now PSM equals fault current divided by CT secondary current rating into current setting. Okay, what is that? 40 divided by 5 into 1.5, which is equal to 5.33. Okay, now for 5.33 we have to find the time from the plot, right? Let me take one more. Where to take it? Yes. Now pencil. Okay. Now for 5.33 PSM, time from the plot equal to 3.8 seconds. What is TSM? TSM equals actual time of operation divided by time for PSM obtained, which is equal to 1.5 divided by 3.8 equals approximately equal to 0.4. Okay, so this is the required time setting multiplier for the relay 2 for the given time margin and whatever is the fault current given, fault current level given. Okay, so basically what we are going to do is the time setting multiplier corresponding to this curve or the curve corresponding to this time setting multiplier should be used to find the actual time of the relay, actual time of operation of the relay. Okay.